What if one of the most common skincare habits people swear by is quietly limiting the very biology it's trying to support? For decades, castor oil has been praised as a natural remedy for skin health. Many people apply it to soften wrinkles, hydrate aging skin, and restore a youthful glow. And in fairness, castor oil is not without merit. It contains ricinoleic acid, a fatty acid known for its anti-inflammatory and moisturizing properties. It can help strengthen the skin barrier and retain moisture. But here's the biological twist that most people never hear about. Moisture alone does not rebuild aging skin. Wrinkles are not simply the result of dry skin. They emerge from a deeper biological shift, the gradual breakdown of collagen, the structural protein that acts like the scaffolding of our skin. By the time we reach our 60s, the body may produce up to 75% less collagen than it did in early adulthood, and the enzymes that degrade collagen, known as matrix metalloproteinases, become increasingly active. So the real question becomes, can a single oil truly influence this complex biology? Modern research suggests something remarkable. The skin behaves like an ecosystem, not a surface. It responds to nutrients, lipids, antioxidants, and signaling molecules that communicate with skin cells called fibroblasts, the very cells responsible for producing collagen. And this is where an intriguing discovery emerges. When certain plant oils are combined, their molecular profiles can amplify each other's biological effects, supporting hydration, reducing oxidative stress, and potentially stimulating collagen production in ways that a single oil alone may not achieve. In other words, the secret may not be what oil you use, but how you combine them. Today, we're going to explore the science behind this idea. We'll look at how skin aging really works, why castor oil has unique benefits, and why pairing it with another specific oil may unlock a powerful biological synergy for collagen support and wrinkle reduction. If you are passionate about natural health and evidence-based wellness, you've found your tribe. For those just joining our health journey, welcome. We're thrilled to have you here as we explore the fascinating intersection of ancient wisdom and modern science. If this kind of deep dive resonates with you, take a moment to hit that like button and subscribe so you never miss our explorations into natural health and human optimization. And I'd love to know where our incredible community is tuning in from. Drop your city or country in the comments below. Now, let's take a closer look at a fascinating question. What actually happens inside aging skin? And how can something as simple as the right oil combination help restore the biology of resilience? Let's begin where the real story of wrinkles actually starts, not on the surface of the skin, but deep within a microscopic network of cells quietly working to maintain its structure. Inside the dermis, beneath the visible layers of the skin, lives a remarkable cell type called the fibroblast. If the skin were a city, fibroblasts would be its master builders. Their primary job is to produce collagen, the protein fibers that give skin its firmness, elasticity, and ability to bounce back. In youth, fibroblasts are extraordinarily productive. They continuously weave collagen into a resilient scaffold that supports the skin like a finely engineered bridge. But with time, something subtle begins to change. Studies from dermatology researchers at Harvard Medical School and the Mayo Clinic show that fibroblasts gradually become less active as we age. Part of this slowdown is genetic, part environmental, and part metabolic. Imagine a team of builders whose tools are slowly wearing out. The collagen fibers that once formed tight, organized networks begin to thin. The scaffolding loosens. Gravity, facial movement, and time begin to leave visible signatures across the skin. This is the biological foundation of wrinkles. But here's the fascinating insight that modern skin biology is beginning to reveal. Fibroblasts are not passive victims of aging. They are responsive cells. They react to chemical signals in their environment. And this is where plant oils enter the story. Certain natural oils contain fatty acids and micronutrients that can influence the signaling environment surrounding fibroblasts. These molecules interact with receptors in the skin, subtly shifting the biochemical conditions that determine whether collagen production continues or slows. Castor oil in particular contains a unique fatty acid called ricinoleic acid. Unlike many common oils, ricinoleic acid has been studied for its ability to support skin hydration and reduce inflammation, two conditions that fibroblasts depend on to function properly. Think of hydration as the working environment for these microscopic builders. When skin becomes dry and inflamed, fibroblasts operate under stress. Collagen production becomes inefficient. But moisture alone is not enough. And this is where many skincare routines unknowingly stop too soon. Castor oil is exceptionally thick. It creates what scientists call an occlusive barrier, helping trap water inside the skin. That's beneficial. It keeps the environment stable, yet because of its density, castor oil does not easily deliver certain other nutrients deeper into the skin layers where fibroblasts operate. This is why pairing castor oil with a second oil, one with a lighter molecular structure and a broader nutrient profile, can create something powerful. One oil holds moisture, and the other delivers signaling molecules that help the skin rebuild. In biology, we often see this kind of partnership. The body itself operates through cooperative systems, enzymes, nutrients, and cells working together rather than alone. When certain oils are combined, they begin to mirror this cooperative design. Some lighter plant oils contain linoleic acid, an essential fatty acid that dermatology research associates with improved skin barrier repair and enhanced cellular signaling. Others contain vitamin A precursors, compounds that are known to support collagen synthesis pathways. The point is not that oil alone can reverse aging. That would be an oversimplification. But the right environment, one that reduces inflammation, maintains hydration, and supplies beneficial lipids, can help fibroblasts operate closer to their natural potential. And this leads us to a deeper philosophical question. What if aging is not just a process of loss, but also a process of biological neglect? When the skin receives the nutrients and support it needs, it often retains far more resilience than we expect. Have you ever noticed how skin sometimes looks dramatically healthier after periods of deep rest, better nutrition, or time spent in natural environments? That's not cosmetic magic. That's biology responding to improved conditions. Our skin barrier is composed of a sophisticated mosaic of lipids, remedies, cholesterol, and fatty acids that function much like a city wall. It protects the underlying tissues, maintains hydration, and regulates the exchange of nutrients and signals. As we age, this wall gradually weakens. Studies from the Journal of Investigative Dermatology show that by the time we reach our 60s, the lipid composition of the barrier changes significantly. Ceramides decline, fatty acid ratios shift, and water retention drops. The result: fine lines, dryness, and a skin environment that's less supportive of collagen production. Castor oil, with its thick consistency and high ricinoleic acid content, is an excellent occlusive agent. It creates a moisture-trapping layer that reduces transepidermal water loss. Think of it like a dam holding water in a reservoir. But while it locks in hydration, it does not fully restore the barrier's lipid composition, the diverse mixture of molecules that the skin actually needs to function optimally. This is where companion oils come into play. Oils rich in linoleic acid, such as rosehip or safflower oil, are lighter, more fluid, and integrate into the skin's lipid matrix. Linoleic acid is essential for ceramide synthesis, the very molecule that forms the backbone of a resilient barrier. Studies from the Korean Society for Skin Research demonstrated the topical application of linoleic acid containing oils not only improves barrier function, but also enhances the skin's ability to retain water, providing a more supportive environment for fibroblasts to produce collagen. When castor oil is combined with a linoleic-rich oil, something remarkable happens. The thick occlusive nature of castor oil locks in moisture while the companion oil replenishes the barrier's structural lipids. It's a molecular collaboration. One oil protects, the other rebuilds. Together, they create a foundation where skin cells can thrive, moisture is retained, and collagen synthesis is more efficient. Picture the skin as a sponge with two layers. the outer lipid layer, and the inner cellular network. If the outer layer cracks, the sponge loses water and structural integrity. Simply adding water or castor oil alone helps temporarily but doesn't repair the cracks. Add a second oil that reinforces the outer layer, and the sponge regains its elasticity, resilience, and strength. That's the principle of lipid harmony. Even when we optimize hydration and rebuild the skin barrier, there's another invisible force silently shaping the trajectory of our skin's health: oxidative stress. This is the biochemical equivalent of erosion on a bridge, the slow, relentless damage caused by reactive molecules known as free radicals. Free radicals are unstable molecules that are produced naturally during metabolism or triggered by environmental factors like ultraviolet radiation, pollution, and even stress. In skin, oxidative stress breaks down collagen and elastin fibers, accelerating the formation of wrinkles and sagging. Researchers at the University of California, San Diego, and King's College London have shown that oxidative damage is one of the primary drivers of visible aging, even more influential than chronological age in some cases. Many plant oils are rich in antioxidants. Compounds like polyphenols, carotenoids, and tocopherols, vitamin E. These molecules not only neutralize free radicals but also reduce inflammation, which is closely tied to oxidative stress. Castor oil provides hydration and a protective barrier, but its antioxidant capacity is modest. When paired with oils high in antioxidants, for example rosehip seed oil, argan oil, or sea buckthorn oil, we create a synergistic effect. The castor oil locks in moisture, allowing antioxidant compounds from the companion oil to penetrate deeper into the skin. This synergy not only protects collagen fibers from oxidative breakdown, but also supports fibroblasts in maintaining their collagen production. Imagine a castle under attack. Castor oil forms the walls, preventing water loss and shielding the interior loss, The antioxidant-rich oil acts like a team of sentinels neutralizing attackers before they can breach the walls. Together, they preserve the structure from both external and internal threats. We've discussed fibroblasts, the skin barrier, and oxidative stress. Yet, there is another layer of aging biology that is often overlooked: microcirculation, the intricate network of tiny blood vessels that deliver oxygen, nutrients, and signaling molecules to every cell in the skin. Think of it as a city's supply chain. Even the most skilled builders and the most robust materials are limited by the roads and delivery routes that bring resources to the construction site. If microcirculation slows down, fibroblasts are starved of essential nutrients, antioxidants, and oxygen, and the skin begins to lose its vitality, elasticity, and glow. Studies published in the Journal of Cosmetic Dermatology highlight how microcirculation declines with age. Capillaries become less dense, blood flow slows, and the delivery of key nutrients like amino acids, the building blocks of collagen, diminishes. Certain plant oils contain bioactive compounds that subtly stimulate blood flow. For example, compounds in rosehip oil, pomegranate seed oil, or essential oil blends can act on the small capillaries of the dermis, enhancing circulation without overstimulation. When applied with gentle massage, these oils can help create a microenvironment where fibroblasts receive more of what they need to produce collagen and maintain structural integrity. Imagine your skin as a garden. Fibroblasts are the gardeners. Nutrients, oxygen, and water are the soil, sunlight, and fertilizer. Microcirculation is the irrigation system. By supporting microcirculation with targeted oils, you are effectively reopening the irrigation channels, ensuring nutrients reach every corner of your skin. We've seen how hydration, barrier repair, oxidative protection, and microcirculation all support skin health. Yet, one of the most profound drivers of aging, often overlooked, is chronic low-grade inflammation, sometimes called inflammaging. Inflammation is a double-edged sword. In the short term, it's protective, but when inflammation becomes persistent, even at low levels, it slowly undermines the body's structural integrity. In skin, Chronic inflammation accelerates collagen breakdown, triggers free radical production, and compromises the barrier. Studies from the National Institute on Aging demonstrate that persistent inflammatory signals correlate strongly with both visible signs of aging and systemic decline. Castor oil contains ricinoleic acid, which has been studied for its anti-inflammatory effects in skin models. It calms irritation and reduces pro-inflammatory enzyme activity. But when paired with oils rich in omega-3 fatty acids, polyphenols, and phytosterols, such as evening primrose oil, chia seed oil, or rosehip oil, the anti-inflammatory impact is amplified. Fibroblasts can focus on collagen production instead of constantly responding to minor threats. Barrier repair proceeds more efficiently. Free radicals are neutralized, microcirculation functions more effectively. We've explored fibroblasts, barrier repair, oxidative protection, microcirculation, and inflammation. Each mechanism illuminates a critical facet of skin biology. But the most profound insight of all lies in synergy, the principle that the whole can be greater than the sum of its parts. In biology, synergy is everywhere. In skin, synergy occurs when different compounds, cells, and signaling molecules interact to amplify benefits. Applied to oils, synergy is the magic that makes combinations more effective than individual ingredients alone. Castor oil hydrates and protects, but it's dense and slow to penetrate. Companion oils, light, nutrient-rich, and bioactive, penetrate more deeply, deliver antioxidants, fatty acids, and anti-inflammatory compounds, and facilitate fibroblast signaling. Together, they recreate a microenvironment that mimics nature, real living systems, balanced, resilient, and self-supporting. Scientific research increasingly supports this. A 2020 study from the International Journal of Molecular Sciences demonstrated that combinations of fatty acids and polyphenols applied topically can produce synergistic effects on collagen synthesis far greater than any single compound applied alone. Use castor oil as the occlusive base to lock in hydration. Select one or two complementary oils rich in linoleic acid, antioxidants, and anti-inflammatory compounds. For example, rosehip plus evening primrose or argan. Apply the blend daily with gentle massage, focusing on areas of fine lines, dryness, or loss of elasticity. Be patient. The effects emerge over weeks, not hours, reflecting the gradual restoration of a living system rather than a superficial fix. Biology thrives in balance, cooperation, and intentional support. When we understand the mechanisms of aging, the very forces that seem inevitable, we are not merely learning to preserve appearances. We are embracing the deeper art of human potential, cultivating resilience in a way that reverberates from the molecular level to the experience of life itself. Skin aging is not just about visible wrinkles or dryness. It is a reflection of deep cellular processes that are continuously influenced by environmental signals, nutrient availability, and biochemical communication. Fibroblasts, the master architects of the dermis, do not function in isolation. They respond to a complex network of molecular cues, including growth factors, cytokines, fatty acids, and antioxidants. These signals determine whether collagen production continues efficiently or slows down. Modern dermatological research emphasizes that optimizing these signals is far more effective for skin resilience than focusing solely on surface hydration or temporary plumping. For instance, studies from the University of California, San Francisco, reveal that fibroblast activity can be modulated by certain bioactive lipids and vitamins delivered through topical applications, meaning that the right molecular environment can actually instruct the skin to rebuild itself more effectively. Castor oil, with its unique fatty acid profile, initiates the signaling by creating a stable, hydrated environment. Ricinoleic acid, its primary component, reduces localized inflammation and stabilizes the outer skin layers. However, to influence fibroblasts deeply, other molecular partners are essential. Lighter plant oils such as rosehip, argan, pomegranate seed, or evening primrose are rich in linoleic acid, polyphenols, vitamin A precursors, and phytosterols, all of which actively participate in cellular communication. Linoleic acid, for instance, is integral to ceramide synthesis, reinforcing the lipid barrier and indirectly improving fibroblast signaling by maintaining a balanced chemical environment. Polyphenols, on the other hand, directly modulate oxidative stress pathways, helping fibroblasts maintain their collagen-producing function despite environmental challenges like UV exposure and pollution. The principle of synergy becomes central here. One oil may provide hydration, another delivers antioxidants, and a third supplies essential fatty acids for barrier repair. Individually, each has a measurable effect, but combined, they amplify cellular responses. Research published in the International Journal of Molecular Sciences in 2020 demonstrated that applying combinations of fatty acids and polyphenols to skin fibroblasts in vitro significantly enhanced collagen synthesis compared to any single compound. This demonstrates that the skin is not merely a passive surface. It is a responsive ecosystem where molecular partnerships dictate biological outcomes. By carefully selecting oil combinations, we can create a microenvironment where fibroblasts receive consistent, multifaceted signals to maintain structural integrity and resilience. Beyond lipids and antioxidants, nutrient signaling plays a pivotal role. Amino acids, the building blocks of collagen, must be delivered efficiently to fibroblasts. While diet provides systemic amino acids, topical oils can enhance local delivery when combined with gentle massage. Studies from the Journal of Cosmetic Dermatology indicate that massaging oil blends into the dermis improves microcirculation, increasing the supply of nutrients and oxygen. Enhanced microcirculation not only supports fibroblast metabolism, but also facilitates the removal of cellular waste products, creating a cleaner, more productive environment for protein synthesis. This mirrors the concept of vascular support seen in internal organ systems. Just as blood flow is critical for organ function, dermal microcirculation is essential for maintaining youthful, resilient skin. Oxidative stress is another critical factor that Keynote 2 emphasizes. Even in young skin, reactive oxygen species, ROCs, are generated constantly through metabolism and environmental exposure. Over time, ROS accumulate, causing molecular damage to collagen fibers, elastin, and DNA within fibroblasts. Here, the synergistic combination of oils rich in polyphenols, carotenoids, and tocopherols is crucial. These molecules neutralize ROS, reduce inflammatory signaling, and stabilize the fibroblast microenvironment. For example, rosehip oil contains high levels of carotenoids and vitamin C precursors, which not only act as antioxidants, but also directly influence collagen synthesis pathways by enhancing pro-collagen mRNA expression. Pomegranate seed oil contains punicic acid, which has been shown in lab studies to reduce matrix metal proteinase activity, protecting existing collagen fibers from enzymatic degradation. When used in combination with castor oil, these oils create both a protective barrier and a functional delivery system for these critical bioactive compounds. Inflammation, both acute and chronic, plays a dual role in skin aging. While short-term inflammatory responses are necessary for repair, chronic low-grade inflammation undermines collagen integrity, accelerates fibroblast senescence, and disrupts barrier function. Ricin snoring locally, but it is the combination with omega-3 fatty acids, polyphenols, and phytosterols in companion oils that amplifies anti-inflammatory signaling. Evening primrose oil, for instance, contains gamma-linolenic acid, GLA, which converts into anti-inflammatory eicosanoids that counteract chronic inflammatory processes. This not only reduces collagen degradation, but also improves fibroblast responsiveness, allowing structural proteins to be synthesized at a higher rate. Another critical yet often overlooked factor is cellular communication through growth factors. and signaling peptides. Certain compounds in plant oils can influence pathways such as TGF-beta, transforming growth factor beta, which is directly involved in collagen production. Studies in molecular dermatology have shown that polyphenols and flavonoids can modulate TGF-beta signaling, enhancing fibroblast proliferation and collagen synthesis. When combined with castor oil, which stabilizes the cellular environment, these signals are amplified and sustained, creating a consistent repair directive at the molecular level. After exploring the microcosmic world of your skin, the intricate work of fibroblasts, the signaling networks that guide collagen production, the protective synergy of oils, and the essential role of hydration, antioxidants, anti-inflammatory compounds, and microcirculation, one truth becomes unmistakably clear. Skin aging is not a passive, irreversible process. It is a living dialogue between your environment, your daily habits, and your cellular machinery. Every choice you make, from what you eat to how you manage stress to the oils you apply, sends instructions deep into your cells. These instructions determine whether your skin maintains resilience, elasticity, and vibrancy or gradually succumbs to dryness, wrinkles, and structural breakdown. The science is now irrefutable. Castor oil provides an occlusive barrier, locking in hydration. Companion oils rich in linoleic acid, antioxidants, and bioactive lipids restore the skin barrier, reduce oxidative stress, and amplify fibroblast signaling. Microcirculation ensures that nutrients and oxygen reach every corner of your skin, while anti-inflammatory compounds calm chronic cellular stress. Together, these factors create an optimal microenvironment for fibroblasts to produce collagen efficiently, repair damage, and maintain structural integrity. Tie this synergy, hydration, nutrient delivery, oxidative protection, inflammation control, and circulation is not theoretical. It mirrors the cooperative design found in living systems and has been validated through rigorous research in molecular dermatology, biochemistry, and nutrition science. Beyond skincare, this principle applies to the broader approach to longevity and health. The body responds to signals, not just superficial treatments. Providing the right environment consistently and intentionally allows natural repair mechanisms to operate at peak efficiency. Skin health, in this sense, is a reflection of cellular alignment, not just surface care. Small, consistent actions compound over time. Daily applications of nutrient-rich oils, maintaining proper hydration, consuming antioxidant-rich foods, exercising to support circulation, and reducing chronic stress all contribute to long-term results that are visible, measurable, and sustainable. The ultimate lesson of this journey is empowerment. Your skin's resilience is not predetermined by age alone. Genetics, environment, and lifestyle collectively shape its trajectory, and you have far more control than commonly believed. When you embrace synergy, consistency, and evidence-based strategies, you are not merely slowing the visible signs of aging, you are optimizing the biology of your skin from the inside out. You are giving fibroblasts the tools, signals, and environment to operate at their natural potential to rebuild collagen, reinforce the barrier, neutralize oxidative threats, and maintain elasticity for years to come. So as you consider your next steps, whether it's applying oils thoughtfully, nourishing your skin through diet, or supporting cellular repair through lifestyle practices, remember this: aging is not an inevitability to endure, but a dynamic process to influence. The choices you make today echo through the microscopic architecture of your skin, shaping how resilient, vibrant, and healthy it remains tomorrow. Your cells are listening, your fibroblasts are responding, and your skin's potential for repair and renewal is waiting for your guidance. Treat it with intention, provide it with the right signals, and you will witness the transformation, not just in appearance, but in the deep structural vitality of your skin itself. Aging does not have to be surrender. It can be mastery, orchestrated through informed action and thoughtful care. And now it's time to take control, because the future of your skin begins with what you do today.